Good morning, friends. Today we will discuss about support structures in rapid prototyping. First, introduction. Rapid prototyping is a group of techniques used to quickly fabricate a scale model of a physical part or assembly using three-dimensional computer-aided design data. Construction of the part or assembly is usually done using 3D printing or additive layer manufacturing technology. The flowchart below shows the workflow in rapid prototyping process. First, a process starts with 3D modeling of the product and then converted to STL format. The resolution can be set to minimize stair stepping. The rapid prototyping machine processes the STL file by creating sliced layers of the model. The first layer of the physical model is created. The model is then lowered by the thickness of the next layer, and the process is repeated until completion of the model. The model and any supports are then removed. The surface of model is then finished and cleaned. Parts may now be ready to use. However, they may also require additional treatment before they are acceptable for use. For example, they may require priming and painting to give an acceptable surface texture and finish. Here we discuss in detail about the support structures in rapid prototyping. Support structure is material created to support the object during printing. As a part is being printed one layer at a time, what will prevent material from falling to the ground, into the undercuts or through hollow features? Something needs to hold layers in place and keep the base material out of the way. By support material or support structures, we can done it. Support structures do a good job of holding everything in place. The printing process starts from the bottom of the printing tray and continues successively layer by layer to the top. This causes problems for overhangs that cannot be printed because there is no supporting layer beneath them. The 3D printers solve this problem by creating support structures for the overhanging parts. The support structures need to be manually discarded after the printing. Some printers use cheaper material for the supporting structures, but in the other cases, the main printing material is used. For example, the FDM printers use the main printing material for support structures. Functions of part supports. Depending on the nature of a particular rapid prototyping process, there will be a need for part supports while implementing the prototyping process. One example is the stereolithography process, where without proper support, the overhang structure would fall down while in the resin vat. For some other processes, such as SLS, no special support is required, since the powder itself actually supports the part during the building process. Some important functions of the part supports are: first one is to isolate part from the platform. The use of supports will make it easier to safely remove the part from the platform after model production. It will also be easier to control the layer thickness and surface quality of the bottom layers. Marks on the platform would not be printed on the final part. The another function is to give supports to parts having hanging structures. The function is twofold. First of all, it provides support to hanging structures and prevents such structures from collapsing. In addition, it can also strengthen overhang regions for the prevention of deformation and curling for stereolithography as well as other processes. Another function is to provide a collision avoidance buffer. The supports also provide a collision avoidance buffer between the platform and other components of the machine, since a different building strategy is applied for building the support structure compared with building the main prototype model. Another one function is to improve the process. To improve liquid flow in and around the part for the stereolithography process, especially during the initial building stage and while switching between individual layers. Depending on design and the application, a support structure may be decomposed into three functional areas. The structure should be designed such that its total weight is minimized. Thus, there are three functional areas for support structures. First one is shearers or needles. Shearers or needles provides connections between the main support and the part. Second one is supports. It is the main support structure. Third one is separators. Separators provides connections between the main support and the platform. Importance of reduction of supporting structure. It is beneficial to minimize the amount of support material. Less supports contribute to the faster printing time, less cleaning of the 3D model, and reduce the overall price of the object. To minimize the amount of support structures required, proper design and selection of supports for a particular part is necessary. There exist a variety of designs for the main support structure. Some of them are gussets. Gussets are used to support lightweight overhanging areas during the part building process and attach to a variety of vertical wall near the hanging areas. Gussets provide the optimal support for overhanging areas while requiring minimal resources during the building process. The supports are also easily identified during cleanup. Second one is projected feature edges. The edges of unsupported lightweight areas where gussets cannot reach are projected downwards to provide support. Projected feature edges support the edge of the feature and provide excellent control against curling and warpage. Other one is single webs. Thin walls can be supported by single webs provided by projecting the center line along the narrow side of the thin walled features. Cross members are added to provide stability of the support structure. Then comes webs. Large unsupported areas may be supported by various web structures. Contact of such support structures with the vertical part wall should be avoided to protect the final part surface. The other one is scaffolds. Scaffolds, various scaffolding structures used in construction and tissue engineering can also be designed as support structures for rapid prototyping. Honeycomb. Other sophisticated support structure is honeycomb. Then comes columns. For isolated small islands, column type support structures can be used. Zigzag and perimeter support. The zigzag and perimeter support structure is most suited for FDM prototyping with a continuous path for each layer. Automatic support structures generation. Based on a given STL model and a building direction, automatically we can generate the support structure. All support structures can be generated according to the inclination angle of a particular facet. First, we check for inclination angle between the facet under consideration and the slicing plane. If the angle is larger than the face angle specified by the user, no support structure is required. Otherwise, the facet requires support structure. The areas that require support for the entire part will be the union of all individual areas identified with the face selection angle. Now let's see a support structure video that shows more about support structures.
Let's take a look at the 4 W's with regard to support structures in your 3D prints. 4 W's? That's why, what, when, and where. W number 1, why? Why are support structures needed? The 3DP1000 3D printer utilizes FFF, fused filament fabrication, which works on the additive manufacturing principle of heating and laying down material layer by layer, creating an object. Support structures are needed when material must be deposited on a layer where there was not a previous layer. This is common in more complex models, which include steep overhangs or hollow structures. You can broaden the potential of your 3D printing by using support structures. W number 2, what? What material can be used for support structures? With a printer that has just one extruder, known as a single extruder, you will likely use the same material for supports as you use for the part you are printing. These support structures simply break away from the part after printing. If your printer has 2 extruders, known as a dual extruder, you have the flexibility to print support structures using different materials, such as water-soluble PVA, polyvinyl alcohol, which dissolves in cold water, making it ideal support material for complex ABS or PLA prints. W number 3, when. When are support structures needed? If your model has areas that overhang, over 45 degrees, you need supports. Let's take a look at a model of a teapot. Due to the extreme angle of the overhang, this teapot would not be printable without the use of supports. W number 4, where. Where do I need to add support structures? This is where the 3D printing software can help you. The software automatically places support structures where they are needed based on the parameters you set. Let's take a look at the Support tab in Simplify 3D. We'll click the Generate Support Material button. Then we set the infill percentage. This is how dense you want the support structures to be. Now let's set the support pillar resolution. This determines the diameter of the support structures. Sometimes it is necessary to dig a little deeper. You can manually add support structures where you think you need them, or conversely remove them where you think they aren't needed. Select the manually defined supports icon and add and remove support structures as you see fit. Once you are comfortable using support structures in your 3D prints, you will not be limited by overhangs or complex models. The sky is the limit.
The figure shows part sections requiring support structures. This is another figure showing the part which requires support structure. Since the entire part requires support structure, we can reduce the amount of support structure by selecting perforated wall with needles connecting to the part surface. Thereby, we can reduce the amount of support material required, and we can reduce the time required for the process and also cost for the process. The present situation is, in the past, support structures were also designed during the CAD session. With today's rapid prototyping software, support structures can now be easily and often automatically produced based on either STL information or contour data. The algorithms based on STL or contour data are much simpler compared with those based on CAD surface or solid models. Thank you.